So welcome everyone to the webinar on better automatic feedback. So today I would like to discuss not only what is good feedback, but also how you can have better automatic feedback in CodeGrade. So some of the theory I'll be discussing is probably known to you, but I think it's a good refresher to go over some basic feedback design principles. And also how to design good rubrics, how to do it in CodeGrade, how you can best link them to AutoTest, and how you can improve your AutoTest. Finally, I'll also show you that once you have those rubrics and those AutoTest tests, how you can also improve your unit test output feedback and your code quality feedback with custom messages for your students. So let's get started with some feedback principles. And again, most of these will probably be known to you, but it's good to refresh them. And it's by no means an exhaustive list. I just think these are some very important things that I found in the papers. So a couple of things I would like to discuss. First of all, what is good feedback? Feedback that is good is educative in nature. So it focuses on what the student is doing correctly and incorrectly. And something that's probably known to all of you is the good old feedback sandwich. So you start with the compliment to your student, then you do a correction, and then you do a compliment again. So you say something you think they did well, something you think that they should improve, and something, again, that they did well. This way, the feedback comes across better to the student. Another thing is from papers from Devin. He publishes a lot of papers on feedback, what is good feedback, both for K-12 education and higher education. And he distilled 4 questions that you should answer in your feedback. So these are questions that are important to your students, and it's important that your students get answers to these questions frequently to keep up to date on their progress and how they're doing. So these questions are, what can a student do right now? What can't the student do right now? How does the student work compared to that of others? And how can the student do better? So these are questions that, if you have a good rubric, are answered in your rubric as well, as your rubric will show them what is expected from them and show them very clearly what they're scoring on the different categories. And also, if the descriptions in your rubric are good, they'll also be very clear to the students what they can do to improve their score in a specific rubric category. Another thing is to provide a model or example. And CodeGrade now supports Markdown, both in the inline comments and in the AutoTest messages. So what you can do is you can use Markdown in your comments to show example code to the student, to give them an example of how they can improve their code. And that actually helps out a lot to the student, as it makes it very clear how they can improve their code on that specific line. So as we can see in this example, I use Markdown here. You can use backticks to have code in your Markdown. And if you press the preview button right there, you will see what it looks like to the student. And as you can see, it renders it as code. So in this case, what they're doing is they're creating their own epsilon constant. And of course, you want them to be using the standard sys Python epsilon constant instead. So to also improve this comment a little bit more is to use your comments also to teach and not just to justify the grade of the students. So if you use your comments to teach, this will activate, of course, the students to make improvements for their future work, especially with CodeGrade. If you have another assignment coming up really quickly, they can use that comment to improve for the next assignment. And what you can also do is make links to the rubric, of course, which is already done by default in AutoTest, as all the tests are linked to a specific rubric category. And you can also link to the course material. So that's what I'm doing here. I'm explaining, using it to teach, why they should better use the constants that are available inside Python, as it's better for consistency reasons, it's better for maintenance, so let's say someone else will pick up their code and work from there. And I also refer to a specific course material that they can find in Canvas or Blackboard or something like that. So finally, two last things. Use the I message in your feedback. And I think this is something that all of you probably already do by default or intuitively, but it's good to make clear that it's good to avoid using you in feedback, as that can be interpreted as a personal attack by students. Instead, it's better to use a generic term like people do this instead of you do this. But what you can also do is use the I message. And with the I message, we mean to communicate what you observe and what you think about it. And that comes across less personal to the student. So instead of saying you didn't spend much time into creating a user-friendly UI, you can say something like, I noticed you did not make your UI very user-friendly. So it comes across as less of a personal attack and more of an observation by the teacher that the student will probably be more willing to take into account. And finally, and this is something you see in all research, that feedback should be given as timely as possible. And it really is, the sooner the better. I've seen a lot of studies that indicate that. And luckily we have AutoTest, and with the AutoTest, of course, we can give the students instant automatic feedback. And in the upcoming slides, we'll go over how you can set that up in a way that also the automatic feedback will be meaningful to the student. So this was just a good refresher again. So now let's go over some practical tips on how you can best design your assignment for good feedback. And I think there's 3 steps to that to set up your auto grading. First of all, of course, we start with setting up a rubric, as that is the start of the assignment. Then we create a test that will fill in that rubric. And then finally, we can improve our tests with custom test descriptions that will make it easier to understand the tests for the students. So let's start with setting up a clear rubric. For both manual and automatic feedback, of course, you can combine these. And a good refresher, as I see in the support tickets we get, and also talking with people, that sometimes the terminology of rubrics is a little bit confusing, and also different schools have different terminology. So the terminology I'll be using is, so the whole thing itself is a rubric, and a rubric consists of multiple categories that all assess a part of the assignment, and each of these categories can consist of multiple levels. So in this example, we have a whole rubric with, in this case, 1, 2, 3, 4, 5, 6 categories. And in, for instance, this first category, code structure and documentation is the name. I have 4 different levels that the student can score on, and this is their score within this rubric category. And now, of course, each rubric category has a name and description, and each of these levels also have a name and description as well. So in CodeGrade also, we added 2 different types of rubric categories. So this is something that is maybe not as usual in other applications and stuff. So we, of course, have the traditional discrete rubric category, and this is the one with these levels, these different boxes. And we also have the one that is continuous. So in this case, instead of having these different levels, you have a sliding scale that goes from 0 to X points that the student can score. So in general, we say we recommend the discrete rubric category for manual grading, as it makes it really easy for a teacher or a teaching assistant to just press on one of these boxes and give a grade like that. And we recommend this one, the continuous one, for automatic grading. This is not a rule. You can really use both types of rubric categories for both automatic and manual. It's just something that we see in practice makes it a little bit easier for you, especially because with the scale here, the connection between the rubric and the tests becomes a little bit more clear and easier to understand for students. And with this one, giving feedback becomes more efficient for teachers as well. So let's go over some general rubric design principles that can help you out create a good rubric. So first of all, within the rubric, within these discrete rubrics categories, we have some levels, of course, that a student can score on. And it's important to think about how many levels you want to be using. The higher the amount of levels you have, the more encouraging it is to your students, as it shows the progress better to them, as they can score different levels. And if they hand in a couple of times, they can see that they progressed over these levels more clearly. Also, if you're going to be manually assessing this discrete rubric category, research suggests that you should be using an even number of levels, as there is a bias towards a middle level. So instead of having 5 levels, where the bias would be to be in the middle one, the third one, it is recommended to use 4 levels or 6 levels, so there's no bias towards a middle level. In general, 4 is recommended if you have large classes and a lot of grading work, as it is a good balance between being efficient for teachers to grade and showing enough progress to the students. Now, within these levels, of course, you have criteria. This is often in the description of the levels where you say you need to do this to score this level, you need to do this to score this level, etc., etc. And with these criteria as well, try to limit the number of criteria per category. If you are finding out that there's too much criteria you're trying to squeeze in one category, it's better to split that up and have that in 2 separate categories. Also, when using your criteria, try to make them clear, bounded, and teachable. So instead of using something like code quality is good, which is a very general term and doesn't really tell the student exactly what they did well or what they did wrong, you should try to make it very concrete by saying something like camel case naming convention was followed, which is a very concrete thing the student can see. They can understand that they did not do that. And if they want to improve this category or this rubric category, score in a higher level, they can implement this in their codes and they know that they'll get a higher score. So that also leads up to the last point here. Make it easy to understand for the students, as a rubric is not just a grading tool for teachers, but mostly a teaching tool and a self-assessment tool for students as well. And to build up from that, there's a couple of questions also for rubrics that you should ask while designing them. These are coined by Van Leusen in a paper from 2013. And those are the following. First of all, question yourself, what knowledge and skills is the assignment designed to assess? Then what observable criteria represent those knowledge and skills? So this is where you're going to be developing those criteria that you'll be using in your levels. And then finally, how can you best divide these criteria to represent distinct and meaningful levels of student performance? And again, what I just said, can these criteria be observed and measured? So is it clear for the student, but also for the teacher? Are these important and essential? Do I need to add them, or is it better to leave them out to keep it as small as possible? And finally, are these distinct from other criteria? Especially if you have different categories, you do not want criteria that depend on each other within different categories. You want these categories as distinct from each other and independent from each other as possible. So this is also something I think is very important, and something I didn't know about until I started researching this, but it's actually pretty obvious, is to try to avoid negative or competitive level headers, as this can of course discourage students. And here are some examples that I really liked that I came across. So instead of saying for intermediate and good, you can say something like beginning, developing, accomplished, exemplary, needs improvement, satisfactory, good, accomplished, as this accentuates the growth mindset and not the fixed mindset. So these are actually encouraging the students that the first level is not poor, it's actually just them having requiring some more learning and some more improvement. And especially with continuous feedback, where they can just improve their code and upload again, having these example or these level headers will encourage your students a little bit more. So to make it concrete, some examples of rubrics inside CodeGrade. So this is a pretty basic one for any basic assignment inside CodeGrade. For instance, in an introductory course, we have 4 different categories, one for code structure, one for functionality, of course, one for code quality, and then finally we have a bonus one to see if you can solve Sudokus of any size. So this is a Sudoku solver assignment, and we asked them to solve Sudokus that are 8 by 8, but in this case, if they also can solve Sudokus of 16 by 16 or larger than that, then they get a bonus point. So to look individually to these different level or categories, the first one, this is a manual rubric category, which is about code structure and documentation. So in this case, we have a short description, kind of explaining what parts are assessed in the code. So mostly we want them to use functions. We want the code to be dry, so don't repeat yourself. So they shouldn't have repeated code throughout the assignment. And also the documentation and clear naming is used. So we start with needs improvement, and that is when they don't have any functions. Then we build up from that, and we see that functions are used, but the code is not structured well because they have unclear variable names, code is often repeat, and the documentation is incomplete. So if they improve those points, they continue to good, where the code is structured better, but still some names can be better, some code is repeated, or some documentation could be improved. And then finally, if all of those things are nice and good, they get to the third category, accomplished, where everything is complete and good. So this makes it really easy for the teacher. Also, they just have to focus on these points, press the level, and they give a grade. Then for the other three categories, these are all automatically tested. We can see that with the AT logo behind it. And all of these are continuous rubric categories. So they have a description that makes it very clear what is being assessed in this rubric category. So in this case, does it give a correct solution to the input Sudokus within 15 seconds? So in AutoTest, we have a timeout for 15 seconds. And if we give it incorrect input, does it correctly handle that and not crash? And also for the bonus Sudoku here, we again use Markdown to point to the file that they upload and very clearly just state what the bonus point is that they can solve Sudokus larger than 8 by 8 within 30 seconds. Then for the code quality one, we say that we use a style guide, which is step 8, and we refer to our slides where we have documentation on the PEP 8 style guide. So this is very easy to the student what they have to do, and with these continuous rubric categories, they will also see the test that will fill them in. And in a bit, I'll show you how you can design those. So that's the total rubric. Now, another one that is often seen, and this is a different type of rubric, since in CodeGrade, of course, especially with more advanced courses, you'll often have subtasks within the assignments. And what you can, of course, also decide on is that you have a rubric category per subtask. For instance, in this case, we have an SQL assignment, and we ask them to create 5 queries. And each of these categories simply assesses one of these queries. And this makes it very clear to the student what is being tested, how they're scoring, and also, especially with these advanced assignments and with the continuous feedback, what is nice is that students can upload incomplete submissions. So let's say they only have query 1 and 2 ready yet. They can just upload query 1 and 2. They get their feedback on these 2 rubric categories, and they see that they don't have any score yet on the last ones, and they can build up from that, and that makes it the progress of the student very visible to them and very smooth. All right. So the next step, of course, is to create a test to fill in the rubric, and afterwards, later on, I'll show you how you can make sure that your unit tests and your code quality tests have meaningful messages. But let's first see some design principles for creating your test. So first of all, if you have a large unit testing script, you may want to split that up into multiple sub unit testing scripts. So it is easier for a student to see the different tests and see also which unit tests correspond with each other or which are grouped together. And this makes it easier for students to see their progress again. for seeing their progress is of course very important to motivate the students. So what you can do simply is have your unit tests, split them up into multiple files, upload these multiple files as different fixtures, and just create different unit testing steps inside CodeGrade and call each of these files in a different unit test step. Very easy, and it will already help out. Then in the IO test, of course, you can use the options for more flexibility. As a student, of course, it can be very frustrating if you think your answer is correct, but the automatic feedback from CodeGrade says it is incorrect. For instance, because you messed up your white space or you printed something slightly different, even though you think it should be correct. So with the IO test options that you can see right here, you have some flexibility to parse the student outputs and to accept more answers. For instance, by ignoring all or trading white space, or making it a substring match. And if you turn on substring match, even if the student prints something like my solution is, and then the solution is underneath that, it will still be accepted as a good solution as long as the part that you are expecting is a substring of what they output. And especially for introductory assignments where students may be somewhat overwhelmed by the output of AutoTest or still learning how to interpret the output of the command line, it's very useful to use substring match so the students will not be discouraged if they think their answer is correct and if it's technically correct as well. Finally, and this is something we'll get to a little bit later, is using custom configuration files for education. So if you have a code quality test and you're using a standard linter, let's say Flake 8 or Checkstyle, it will often just lint everything that is possible. What you can do is you can create your own configuration file, and we do have some guides about this, and we had a recent webinar about this for Java as well. And what you can do is ignore complicated or unwanted errors that you don't want to bother your students with. Just take them out of the configuration file and it will not check those. Also, what you can do is focus on some messages and errors that are especially important to you at the stage of the student or for the type of assignment or course that you are creating or giving your students. And you can just use those to very focusedly give feedback to the students using one of these code quality steps. If you want more information on that, we have a guide, and later on I'll tell you a little bit more about that as well. So finally, what I think is very important, and I'll show you how you can do that, is writing custom test descriptions to make the test that you've set up more understandable to your students. And well, you can see right here how you can do that. So each test or step inside CodeGrade, you can add a description template, and this description template will then be the name of this test. So in this case, we can see that we call it check assignment 1.r for correctness, and that is also what we see here displayed to the student. And there's some design principles to this as well. To make sure to describe what the test assesses, especially sometimes if you have some more advanced assignments, you may have big or complicated commands to execute the student code or to execute your testing script or whatever. And those commands can be very confusing to the student as they don't really describe what the test is assessing. They just describe the commands that you're executing. So if you use these custom test descriptions, make sure to describe exactly what the test assesses so the student understands why they're passing and failing and they can learn from them. Also, this may be applicable to some courses, is to make sure that the test should still be locally reproducible by the student. It can be very, very annoying for a student if they see that they failed a test, but they do not understand how they can replicate what is being done. So if you are adding a custom test description, make sure to also explain, if needed, if applicable, how they can reproduce this command that you're doing on their own local system. Or if they're using an IDE or something like that, how they can reproduce that in their IDE. Finally, and this is something we talked about earlier, Markdown is also supported in these custom descriptions. So you can add example code to this, you can add file names to this, and you can make it very clear. Also, you can make things bold and you can make things italic, and that will just make it easier to style this in a way that the students get their example code or they get the reference to the documentation or your course material very easily. So let me show you how you can set this up. So I have a simple Java assignment, or this, Java assignment here. This is the Sudoku solver again, and I have an IO test right here. So in this IO test, what we do is we run the Sudoku solver, we give it an input, and then we expect the output. Now, if we want to add a custom test description to this, that is very easy. All we have to do is scroll down all the way to the advanced options here. So please note, there's a couple advanced options here that you can see. These are for the individual input and output pairs that we have. The one all the way on the bottom here is the one for this whole test step. We can press on it and we can see that we have two input fields for our description templates. One is for the whole test and the other one is for the sub-steps, so for the input and output pairs. Let's show you that here. So if you see this image right here on the bottom right, we have the one, just number one right here, which is the description template for the whole test. And then for each sub-step, so 1.1, 1.2, 1.3, we have different descriptions as well. And that is what you write out. Now, the last thing that you can add are these substitutions. So we have made a couple of substitutions available here that you can use to substitute things that you write out in your test. So for instance, you can substitute the input, argument, the command, the name of the test, you name it, to make it more personal. So in this case, let's give it a test description. So testing functionality of was the Sudoku solver of Java. And then right here, what we can do is testing with input, and then we give it a name here. So we named everything with input an easy 9x9 Sudoku, medium 9x9 Sudoku, and a hard 9x9 Sudoku. So testing with, and then we say name, as we can see right here, then it will substitute testing with an easy 9x9 Sudoku. So let's make this bold now so it's easy for the student to see. I think that's 2 stars. Yes, so now what we have made it very clear what we are testing. So in this case, we're testing with an easy 9x9 Sudoku or with a hard 9x9 Sudoku. And right here, we're saying we're testing the functionality of Sudoku solver of Java. So this makes it very easy for a student to understand what is being done right here, especially if they do not yet understand what, for instance, the command Java Sudoku solver means, or that you are giving this input via the standard input or things like that. So if we save it now, we can see that it also changes right here. And now it is a lot more clear than it was before. And this is available for all different types of tests. As we can see right here, for the unit test, we have also added it. And we just make it a little bit more clear to the student what is being done. So run the unit test from test3 Sudoku Java, which is a file from fixtures that we've not hidden and they can open. And that is a way more clear to the student than seeing the command cg_JUnit4 run test3 Sudoku, as the student doesn't even know what cg_JUnit4 means, as that is something inside CodeGrade. All right, so that is the last step, but of course, the last step really is how we can make the test output of, for instance, a unit test or a code quality check more easy to understand for the student as well. So that's the next step. Yuri, are there any questions that we could go into? No? Oh, great. If there is any questions, feel free to let Yuri know in the chat. Cool. So For unit tests, I will go over Java and Python, the most common ones, and I'll start with Java with the JUnit 5 unit testing framework. And there's a couple of things that you can do here to make it easier for the students to understand. So you can add custom descriptions and names with the display name decorator, and you can add custom weights with our built-in weight parser that is specifically for JUnit 5. So let's start with the display name here. And what we can see is that if we import the display name and we use it as a decorator, so that's what we do right here. So with our test that we have right here, underneath the test decorator, we add display name, and then we add our custom description right here. And if we see the output right here in some CodeGrade, you'll see that this custom description that we write right there will be shown to the student. So that makes it really easy for a student to understand what you're being, what is being assessed. Then finally, also if you want to add a specific weight to it, especially for JUnit 5, we've added custom weights, as JUnit 5 does not have a decorator for custom weights. What you can do is in your display name, you can add with block, what are these things called? Block things? Block
quotes.
Block quotes?
I think so.
All right, well, if someone knows, let me know. With these block quotes, you can add the weight that you want to add to this test. If you do not have that, it's by default the weight 1, but if you add it, it will be the weight that you put in between. So in this case, as you can see, we have the weight 1 for the test above here, and we have weight 2 for the test, second test. So this makes it really clear to the student and also allows you to have some differences in weights between the tests if one is more important than the other. Is this well readable, by the way? Well enough? Great. Square brackets. Thank you. Yes. Brackets, that's the word. All right.
What quotes are those triangles?
Yeah. So for PyTest, we can do the same. And what we can do is we can add custom descriptions or names with the record XML attribute function inside PyTest. And we can use this function to modify fields in the JUnit XML that is outputted. And JUnit is not a typo here. So what we do with these different unit test wrapper scripts is that we parse the JUnit XML. So PyTest can output a JUnit XML file, which then is parsed by CodeGrade. And most unit testing frameworks, including PyTest, have a function available to edit fields in this XML file that it outputs. And that is also the one that we'll be using to change the name and the weight values, which will show up in the unit test tab. So how we do that practically is in our PyTest tests. What we do is we use the record XML attribute function, which we have to give as an argument to our test. So don't forget that, as you can see right here. And we change the name attribute, and then after that, the second argument to this function, we can give the name that we want. And this will be the name that shows up right here. So a custom PyTest name by changing the XML name attribute. Now, we can use the same function to also change the weight, and we do that down here very easily. We just change the weight attribute this time and we give the value of 2. And as you can see right here, this test now has a value of a weight of 2 and a custom name as well. And again, all the others that we didn't change the weight attribute for have a weight of 1 by default. Also, what we can see right here is that for these others, it just uses the function name instead of the custom name that we've given. And even though your function name, of course, can be very descriptive, which is even a good practice, it is always nicer if you can have a full sentence to explain what this test is assessing, so the students can understand that better. So if you have another unit testing framework that you use, You can use the same JUnit XML file for most of them to customize the values to change the description, the name, or the weight. And most of the times, these values are called name and weight, and you can just change them. If you want to know how to do that for another unit testing framework, feel free to just reach out to us, and we'll be happy to help you out and look into that. Something similar can be done with code quality steps. And for this one, we'll start with Java, because unfortunately, this is not yet possible with Python. So this is not something that is built into Flake 8. However, it's built into Checkstyle and PMD. And you can change the descriptions and names with the message property. And you can also customize the severity level. And we've written a blog about this, so if you want to look this up, you can see it on our website. Also, I'll write a blog about this next week, and you'll be able to see all this code in the blog as well. So for PMD, we can change the message attribute, change the message that is displayed on the line inside CodeGrade. And as we can see with the rule here, in our configuration file, we change the message name, and the priority can be changed as well. And this is the mapping. So 1 is fatal, 2 is error, 3 is warning, 4 is info. And this is all in our configuration file, so in our XML configuration file of PMD. If you want more information on that, again, you can see the last webinar on that of Java autograding. And Checkstyle, something very similar. We use the message property this time, and where is it? There we go. The key can be found in documentation. That is different for each different test that you have inside Checkstyle, and then the value can be changed here. That's the message that is shown up. Why this key is different is that there is also placeholders here that you can use to customize the messages. And that is very useful, and all of that is also documented in the documentation of Checkstyle. Finally, the severity can be changed to a value of info, warning, and error, and these correspond with the info, warning, and error in CodeGrade as well. Fortunately, there's no fatal inside Checkstyle. But of course, inside CodeGrade, you can change the penalties you have for these different severity levels. So if you want to replicate fatal, you can just give error a 100% penalty. So for the other static code analysis tools or linters, fortunately, Flake 8 and PyLint do not have this feature out of the box. What we are looking into right now is to add some sort of universal custom messages inside CodeGrade, or at least bring some type of wrapper script that will allow you to make this work as well for Flake 8 and PyLint, but also for all the other linters that you may want to use. That's something we're researching, and we'll get back to you about sometime later. But if you need some help with your specific code analysis tool that you're using, and you want custom messages in that as well, just let us know, and we'd love to help you out. Finally, something new that we've added are guides for adding your own linter or adding your own unit testing framework to CodeGrade. So in our help center, we now have a guide on how you can write your own wrapper script to add your own new linter to CodeGrade, which maybe makes it a little bit more insightful to you as well, how you can change these custom messages and security levels for the linter that you want to add. All right, so that is it. So what we talked about is first how to give good feedback. What exactly is good feedback? Hopefully after that, I could make it a little bit practical with how you can incorporate that in your rubric and your AutoTest inside CodeGrade. And finally, showing you how you can change the messages and the security levels in unit tests and in code quality tests. Fortunately not for Flake 8 and PyLint, but we'll get back to you about that soon. And hopefully you'll be able to, with the refresher of these good design principles of feedback, you'll be able to incorporate that in your messages as well in your unit test, your code quality test, but also in your rubrics and your auto test. And if you want more help, of course, let us know. We would love to help you out as always. Or join the Discord channel, and we'll be even quicker to help you out in there.